So, welcome to today's Dynamo office hours with Saul and Jacob. We are still doing the writing the Stairry story. I think this is what the third part potentially of this third. We are happy to have you. My name is Tiana. I am a community program manager here at Autodesk. I am on the community team, and this is part of our community conversations that we run. Basically, community conversations, we have expert speakers from the community as well as from Autodesk itself come and share their knowledge and help or start making connections and things like that. So yeah, welcome. This is our safe harbor statement. Basically what this is saying is that do not make any forward-looking or any purchasing decisions based on any sort of forward-looking statements or statements that are made by Saul and Jacob today. I'm here to help get any of your questions answered if you have them in the chat and things like that by Saul and Jacob. And I will hand it over to them to introduce themselves.
Cool. So I am Jacob Small. I'm a technical consultant based out of Boston, Mass, but originally from Londonderry, New Hampshire. So there's some ties there. Describe myself as a Dynamo forum junkie, really involved in the larger Dynamo community. You can catch me helping users at all hours of the day and night off in the Dynamo BIM forum.
True facts. I saw Jacob answering responses at 3 a.m. Local time one time, which was a bit nuts. Anyway, hi everyone, I'm Saul. I'm the product manager for Dynamo. I'm not from New Hampshire. I'm actually originally from New Zealand, but I have traveled to New Hampshire, so there is that. I describe myself as a curious human being, also based in Boston, Massachusetts right now. All right, so welcome. Thanks for joining us today as part of our Dynamo Office Hours series. We have number 42, so we have a lot of before content. If you haven't seen it, please go check it out. We'll put some links in the chat. And this is the third in a three-part series around specifically workflows in Revit. The first of that series was building a stair. The second was flexing it and making it more detailed. And this one is called Writing the Stairry Story, which is essentially talking about how we document some things inside of Revit using Dynamo. So as per usual, we're going to have a presentation. This is going to be roughly 20 minutes, and then we're going to do a live demonstration where Jacob's going to show you some really fun things. There's a Q&A, but please do interrupt us at any point in time if you do have a question. We want this to be a conversation, not necessarily a presentation. So we would encourage sort of interruptions and do find that to be more fun than just waiting till the end. So please do.
All right, so last time on Dynamo Office Hours, because this is a continuation of the series, this is what we put together. We built a graph that would basically write all this up. Obviously, I've sped this up a little bit for anybody who saw the last version. It did not go quite that quickly, but it did get all of that geometry sort of created. I've pushed it a little bit further and took the lighting recesses and actually baked them in as well. We'll have a quick tour of the model when we get started and looking at the actual demo portion of today's session.
All right, so we're going to talk through a handful of documentation pieces inside of Revit. In this case, looking at all the cool stuff and starting with views. So there's a little bit of nuance when it comes to the Revit API, and that is expressed in Dynamo as well. So the way that you build some of these things that we're going to talk about are going to be conceptually a little different to the way that you might engage with them using buttons inside of Revit to do the same actions. So you can create many different types of views inside of Dynamo. You can see them in the image here on your screen. And there is a Revit API for those of you curious or brave enough to go and check it out. There's a link here, just apidocs.co. So a big shout out to Guy Tellerico, who creates and maintains that project. And the thing you need to consider really is that because there are different ways to create views, you need to define the how of you're going to create that view. So some of these could be things like by level or by target in the context of a 3D view. So you can conceptualize a 3D view being more like a camera. You have to say where it is, where it's pointing to, and what is the sort of the frame of reference or the thing that sits inside of that view. You can then sort of modify those views, which we're going to talk about a little bit later under sort of the view category inside of Dynamo. And there are also packages that exist out there that allow you to deal with creating views in slightly different ways. So some of these could be Archilab or the rhythm packages, And they some of these packages also sort of collapse multiple of these sort of granular steps that we expose out of the box into a single node that sort of does part of the heavy lifting for you. And one of the things to think about, and let's get sectional, I guess there's a song associated or correlatory to that, but they can be a little bit tricky. And to think about them when you're generating them using the Revit API, they have a default setup that might not be sensible or might not be intuitive, is a better word, to people creating them. So in the case here, if you're creating a section view, it's not actually going to be like you would be drawing one inside of Revit. It's going to be on that ground plane looking up. So the basis is actually looking upwards. And so what you're going to see inside of your section view is going to be a little bit strange. So what you have to do in the two nodes that are created here by bounding box or by coordinate system min max point, one of them will create it at the base point of the geometry you're referring to, and the other one will create it actually at the centroid of that geometry. They're essentially facing up into the sky. So not functionally useful just by using them naturally. So what you really have to do is start thinking about how to use matrix transforms, which is a fancy way of saying, like, we want to tell this view what its orientation is and what its location is to be able to actually see the stuff that we want to get into. So if you see on your screen here, the view in CN is what you can see, a section that has been created naturally using the dot by bounding box method, which is drawing the cut plane in the wrong orientation and just showcasing things up into the sky. And then we need to go and do something like using a plane on the XZ plane to actually generate that section in a way that might make sense to your average user inside of Revit who's thinking about sections. So in essence, what you really need to do here is to understand coordinate systems to effectively use these kind of approaches.
Yeah, so to put a bit of a finer point to that, because these are quite confusing, put together kind of a little quick tutorial here. So as we know, all views have kind of a cut plane, a crop box, and a depth, right? Those are pretty standard, but some views have additional metrics, like plan views have a top, a cut plane, a bottom, an offset from bottom, so on and so forth, right? Really, we typically want to sort of focus in on just this content in particular when we're making sections. But again, it's important to note that other view types are going to have much more elaborate stuff. Now, it's also important to note that the values that we define in the Revit API are not necessarily going to be represented the same way that we might sort of think of entering them into our properties palette, right? Far clip offset is a pretty clear description of, how far back do we want this view to go? But the Revit API doesn't really work that way. So let's talk a little bit about what's happening under the hood. So to sort of explain this, I started by drawing my best impression of a Monopoly house in Dynamo using as few nodes as possible. And so any view, before we can create the view, we have to have something to look at. So we're going to look at this house. And then we're always going to start by sort of defining a cut plane. This is going to be defined by a coordinate system where the normal of the plane is going to be the coordinate system's z-axis, right? So that means our cut plane is always going to be that XY plane, right? You can see it there. So the basic parts here, we've got our coordinate system, right? The actual cut plane, which is the XY plane of that coordinate system. The Y-axis, we want to be the up direction of the view. The X-axis is going to be the left-right direction of the view. Then from there, on that plane, we can define a couple points. And these points are basically going to define the crop box of this view, right? How big does this view want to be in terms of its width and length? We're going to define that by taking the two X values and subtracting the 2 from these 2 points and the 2 Y values of these points and subtracting the 2. And that's going to give me the height of the crop box and the width of the crop box in model scale, not on view on page scale, but in model scale. And then with those two pieces, sort of defining that crop box, again, you can see that midpoint there, the max point there, and the rectangular crop there. With those two pieces, I can then extrude it out to get a depth to actually get the view depth set up. And that's going to be set to my maximum Z value. Now, is that all confusing? Yes, absolutely. No way around it. It is really crazy stuff because we're starting to talk about effectively defining a bounding box, right? Min point, max point, but we're not defining our bounding boxes on our standard global axis. That's what we've always talked about, bounding boxes having always been XY aligned, XYZ aligned. It's no longer entirely the case. In fact, it hasn't been the case in Dynamo Sol, correct me if I'm wrong, but 2.16, we got the capability for off-axis bounding boxes, which is really cool. And it's always been the case inside of Revit. So since this is confusing, should we do a demo? Yeah, let's go ahead and do a demo, but just a quick one, I promise. We're not going to go super long because really all I have to do is open it up and kind of explain how this is working, because the static images we showed before weren't necessarily great. So you can see I've got my house here. I'm going to go ahead and turn off that preview, and we're going to look at this preview instead. This is going to sort of gray that house out, make it translucent so we can sort of see through it. And then from here, we have our different parts and pieces. So the first piece we have is our view plane. This is going to be our cut plane. We'll turn the preview on for that. I've currently set this up to be a plan view. Then we're going to go ahead and we're going to display kind of the extents on this plane. When I turn this on top of our plan view, our plane, we're going to see this bounding box gets created. Again, and that bounding box is in the direction of that plane. So I know I said it's a plan, it's really a reflected ceiling plan. Sorry, I got that backwards. And then last but not least, we're going to set this up to preview our cut geometry, right? And so since this plan, reflected ceiling plan, is currently set to the very bottom of the house, we just get that kind of static piece. Now I can change my view type. So let's go, instead of my plan view, let's change this here so that we get a section. You can see I'm now cutting a section right at the front of that house. And now we can start to change our location data. So I can move my X location, and that's not really doing very much for me, right? It's shifting my bounding box around, but that's not really very useful. We can then take my Y location, we can adjust that, and that's going to change my depth, because I'm adjusting this relative to my, or not my depth, but my cut plane through the house. And I'm not sort of adjusting this kind of on the local XY to the plane, but I'm adjusting it in the global XY. And then last but not least, we can adjust kind of the height as well, again, on the global XYZ axis. From there, we can start to adjust our minimum depth. So we can take this piece and we can sort of extrude stuff out. We can set it to whatever depth we might want relative to where stuff may or may not want to cut on its X, on its Y, and on its Z as well. Right. And again, this is going to sort of change how far back do we really see stuff relative to the overall scope of the drawing. Similarly, we can adjust the maximum depth for the X. So you can see we're not viewing all the way up through there. We're only viewing part way, maximum for the Y, and maximum for the Z. How far back do we want stuff to sort of go? And that's basically how that content all works. So again, just changing that coordinate system will sort of switch up our bounding box and allow us to view stuff kind of in a different direction. So hopefully this all makes some sense. I know there's quite a lot to it, but it's really confusing without that. So I'm going to go ahead and close this. Won't save any changes, and we'll pop back over to the PowerPoint and talk about adjusting the views.
Right, cool. Thanks, Jacob. So what you might have noticed is Jacob has kind of just gone in a simplified version, recreated some of the tools that kind of exist in Revit today around sort of crop boundaries, crop views, orientation, and so on. So conceptually, hopefully that starts to paint a picture about the level of complexity that's kind of required when you start to think about views and what that actually means. You know, what content is in there, how big are they, what can you see, what is the orientation, and so on, which is why they're a little bit tricky to use inside of Dynamo. But when you do wrap your head around them conceptually, they start to make sense, and you can start to do some pretty cool things, which we're going to show in the real sort of demo later. So once you've created a view, you can also do stuff to the view. And so we want to really make them look good. So instead of just having a view created and you're good to go out of the box, it's not quite the case. We've got all of these things that you can see on screen here that enable you to do other cool things to them. You can do stuff like setting the view scale, hiding or isolating elements, applying filters, setting the rendering style, and so on. There's a bunch of different sort of aesthetic choices or detail choices that you can make to make your views look really, really, really cool programmatically. And then the same thing with creating views, you also have the ability to create sheets. And this is around putting those views on sheets or putting things on a page. And sheets can also be created in a variety of ways. So we had about 2 different options out of the box today for creating views. And we have about 5 or 6 different options to create sheets out of the box too. So these options give you different choices. Some of these choices about just simply creating a sheet with nothing on it, such as the first one in this list. The second one is around creating a sheet with a view on it. If you want to automatically start collating those things together, you can do the same thing with multiple views. You can do the same thing with putting the views on a sheet and also choosing their location on the sheet when you want to get really particular about it. And that can happen in both a singular or a multiple way. You also have the ability to do things like duplicate sheets. So these ones actually are much more straightforward and conceptually easy to wrap your head around than view creation itself. And the reason for that is because they really only exist in the XY plane, where views can exist in any combination of X, Y, and Z, rotation, location, orientation, and so on. So the matrix of possibilities that exists with views is much, much higher.
Very good point. All right, and then on to the last bit, other things that you can automate. Now, just because we've managed to create our views and create our sheets doesn't mean our automation is done. There's plenty left out there for us to do. Some of the things you might want to consider would be placing detail components or detail lines or dimensions, text notes, tags, annotations, all that sort of stuff that happens after we get that sort of model put together and this original set cartooned out can be automated to some extent. Now, there are some limitations, some things that you can't automate and some things that you might want to keep in mind as you go. In particular, the known limitations in terms of annotation and sort of making the views look good on the page that sort of tend to drive me nuts are line work and keynotes, right? I can't automate creation of keynotes at this point, nor can I automate sort of adjusting line work, right? If we wanted to sort of override this one portion of this line so it's dashed or red to draw attention to it or whatever else it might be, not something that we can currently automate. There are other ways to sort of work around those pieces, but it's something to sort of keep in mind as you're looking into stuff. The last thing to sort of mention here is transactions. And transactions are, in particular, depending on how your nodes are set up. And when I say nodes set up, I don't mean your graph. I mean the authored nodes under the hood can have some pretty big impact on how stuff works. John Pearson actually has a great post on the Dynamo forum, which I think I might still have up. Yeah. So John, who I see in the chat, hey John, has a great post in the Dynamo forum, sort of showing how these transactions kind of can drive people nuts, right? So you can see here we've got an initial piece that sort of attempts to set the crop box for a view and then place it on the sheet at the correct size. And it doesn't work the first time out. So he goes ahead and he modifies it to sort of connect stuff up a second time out with that additional transaction in node in there. You can see it's now placing on the sheet at the correct dimension. Now, the reason for this is things have to sort of be committed to the database before they can be recalculated in many instances. And this is probably the most classic example of that. We've seen it in other places around stuff like setting view over or line work overrides line style overrides for crop regions, or sorry, not crop regions, field regions. There we go. It's a region. And stuff like that. So you will see that out all over the place. And I will go ahead and put this in the chat in case anybody wants to do a little bit more research on it. Here we go. All right, cool. Now, with that said, anything to add to that? Other stuff you can automate, Sol?
No, there's a lot of nodes, right, that exist in Dynamo for Revit. So please go have a look and see what you can do. There's also a lot of awesome things on the forum and a lot of awesome YouTube channels, a lot of awesome blogs and so on out there showcasing a bunch of this different stuff. And also a big shout out to the package authors who create extended content beyond what we have out of the box too. So one of those being John in the call, which we gave a shout out to earlier with the rhythm package. Please go check out that stuff because some of those nodes do collate sort of numerous different steps into one, which can help fast track you to get you to the end result. But the more granular approach that you have gives you infinite control out of the box. You just kind of have to understand how it works conceptually, which we've tried to sort of illustrate a little bit today.
Cool. On the subject of packages, shout out to Andreas Deichmann for the detail component by curve. I still use that all the time in my day-to-day work. It's one of those things like, how would I get by without this? So again, huge thanks to all the community members who make Dynamo the great thing that it is. All right, so with that said, let's pop over to our live demo. We're gonna jump over to Revit, and you can see here, we've got our stair as it was before with a few additional changes. In particular, I'm gonna go ahead and isolate this view. Sorry, swapping back and forth between Civil 3D and Revit all day as my, where's my isolate command a little bit backwards, but you can see I went ahead and I inserted that light recess in there with the correct form, those additional cuts. It is still that solid element. So you can see it's got its solid geometry. It's set to sort of render correctly and shows up well within our model. But we can't really, typically, we can't get stuff built directly from a 3D model, right? We've got to go ahead and we've got to document what each one of these pieces are and put the specifics of it together. So let's go ahead and let's start Dynamo to do just that. Where is my Dynamo? Here we go. And I'm going to go ahead and open my sort of pre-baked graph here, which is going to do a whole bunch of stuff. And the basic idea, sort of my map for this graph, I wish I'd planned on presenting this to you guys in hindsight, is we want to go ahead and we want to gather all the generic models for our stair. So we're going to take all the elements of category, make sure we get the stuff that's equal to feature stair. Then we're going to go ahead and we're going to pull the element name from those elements. Make sure they're equal to feature stair, filter the content out so we've got just the stuff that's equal to feature stair, right? So no matter how many pieces I have, because all of these families that I've placed have feature stair part as part of their name. It's a pretty quick and direct way to do that. And I can take advantage of this because I automated the creation of those with that name. So I'm going to go ahead and hit run. And I've got most everything frozen. So we're not seeing too much here, but you can see we've sort of narrowed stuff down to just the generic models we want. I'm not grabbing the handrail. We'll work with that at another time when it comes to documenting. And then we're going to go ahead and we're going to start talking about the next step here. So I'm going to turn on the this node. We want to keep the preview on. This is going to attempt to pull all the geometry from our stair parts rather. So it's going to go in and convert the solids, the surfaces, the curves, and everything else from our original element over into, from Revit geometry elements over into Dynamo geometry elements. And this is not where I expected this to freeze.
Quick, Jacob, tell a joke.
I don't have any jokes prepped this time. All right, there we go. Oh, wow. So it finished what it was up to, but not really well. I'm pretty sure I have more than 5 parts to my stair, right? And so what we're actually seeing here, if we zoom in on this and check our warning, 1 or more geometries have failed to convert due to this error, failed to trim surface with polycurved loops, coincident region. There are 2 curves with coincident regions. It's a whole lot of gobbledygook to most people, including me. All I need to really know is, hey, we couldn't convert the geometry, right? So we've got to try and figure a way around it. All right, well, back to the drawing board, therefore back to the PowerPoint. Sorry, everybody. Let's talk about element geometry rows. You're going to run into this all the time as you get into more complex geometries. Revit geometry is not the same as Dynamo geometry. They're 2 completely different things, different engines under the hood, which means they have different strengths and weaknesses. Now, as a result of having 2 engines, we have to convert from Geometry Engine 1 objects to Geometry Engine 2. Obviously, something simple like a point, well, that's pretty easy, right? I've got an XYZ data in Revit. I've got XYZ data in Dynamo. Really easy to bounce back and forth. Something complex like, oh, I don't know, my stair, it's got a lot more to it. So we're more apt to find sort of breakdowns in these conversions as we get to those lot more to it. So when our out-of-the-box geometry fails, one of the things I like to do if element.geometry fails, try to get just the data that you need. Since all I need is the top walk surface of my stairs, I can just move right over to element.faces and get that content. So my next step would typically be to try that. I did. It also failed. So where do we go from here? Well, we don't just start crying and move on. We try and solve the problem. So when geometry conversion isn't literal roadblock. I always go back to focus on my goal, review the map, talk about what it is that I need. Then I go into my Revit geometry options and look into the Revit API and sort of figure out exactly what it is that I'm after. So anytime you pull out the geometry with the Get Geometry feature of the Revit API, you're going to come back with this geometry object class types. Those could be faces, curves, solids, etc. These are very similar to what you can do with Dynamo geometry, but less flexible in many ways, and also very hard to see because they don't have any kind of display. There's no way to draw a curve in Revit. There's no way to draw a face in Revit. I can make objects that have a face display, but I can't make that geometry directly, right? So that's something to keep in mind.
And one thing as well, as John said, custom packages do express some of these API calls that out-of-the-box nodes don't have. So I believe Clockwork has element.geometry plus, which allows you to get a little bit more than the element.geometry node does today, although we are working on improving that node in particular in the very not too distant future.
Yes, great. And great point, thanks, John. All right, so let's talk about my scenery here. So my goal is to get the radial axis of each tread, right? So I've got these series of treads that are sort of radiating around in a curve. I want to get the dead center of each one of those treads on that axis. The way I'm going to do that is I'm going to get the top face of the tread, which is going to be a planar face type, which is great because, as I mentioned, simpler geometry, more likely to convert. So we're going to go ahead and we're going to get the geometry object, check if it's a solid or if it's instance geometry. If it's instance geometry, meaning we've got a family that's got an instance of it placed and it hasn't been modified, we're just going to go ahead and pull that geometry from the instance. If it's the actual geometry, because it has been modified, we'll pull that geometry directly. We'll get the solids from all those pieces, union them into one solid, pull all the faces from that solid, filter out anything that's not planar, group the planar faces by their orientation because I want my tread's pointing up, and then we'll go ahead and we'll combine the groups into a single dictionary and output those into Dynamo. So the different parts of that process, setting up my Python, going ahead and setting up my inputs, running the bulk of my code, and returning the results into Dynamo. This is where we're going to focus because that's where the bulk of this content is. So again, step one, get the geometry. So that's element.getGeometry, and I need some options for that. I define my options up above, but it's basically just options. I didn't pull anything fancy from those. From there, we're going to check if it's solid or instance geometry, right? So we test, is there solid in the geometry objects list? If the test did not pass, then we're going to go ahead and we're going to pull the geometry objects from the geometry instance. From there, we'll go ahead and we'll get the solids from that resulting list. So getting rid of any other geometry that might have snuck along, like if I had a face in there or if I had curves in there, we'll go ahead and discard those because I'm just working with my solids here. We'll union all those solids into one union solid. So instead of having a collection of solids, we'll have a single one. And then we can go ahead and we can start to pull faces from those individual solids, but with the union solid.faces line there. Filter out any of our non-planar faces by saying, hey, get me the type. And if the type is equal to autodesk.revit.db.planarface, we can pull that directly. I did do an extra string conversion in there because I was getting some weird results, but anyways, there it is. And then we can go ahead and group by the planar faces orientation, convert those planar faces over into Dynamo faces, and then return those results as a dictionary to the Dynamo environment, right? All that little bit of code is the sort of stuff that I can reuse and I have actually used on other projects in the past and will probably use again in the future. So it's one of those things where as a computational designer, you put this stuff together and just pull it aside, keep it ready, keep it handy for later, put it in your back pocket. So all of that said, let's pop back over to our live demo. So I'm going to go ahead and I'm going to unfreeze this and this. Didn't mean to have that one frozen as well. We'll go ahead and we'll get rid of this failing node because or failing node. And I'm going to go ahead and I'm going to turn on the preview for this. I'm also going to put a temporary holdout here so I can run this bit, but not everything after it. So again, it's got collected all my stuff, pulled them out, and you can see the outputs of this is now a dictionary. So I can pull my a list of dictionaries. I can pull these out and then ask from that dictionary, what's in the up portion of my treads. You can see that content kind of pulled out there. There are the only up facing pieces. If I wanted to look at my down, there they are. If I wanted to look at the vertical, there they are. And I can do that for any index in this dictionary. That one's much taller than I expected. But with that, because I've got that, I can now continue about my graph. So pull this over. How am I doing for time? I've got my camera hiding that. 34. Okay, we're good. We're good. All right, so went ahead and ran. Didn't run everything, which is good because I didn't quite want to run all of that stuff yet. Or did I run everything? Well, that's interesting. All right, my virtual machine is in a bad state. So instead of having to reconnect everything, it is time to do a restart of Dynamo. I should have seen that coming when I had that unexpected delay. That's what I get for having the same Revit session open for a couple hours before starting a live demo.
So as in the downtime, there has been some stuff shown so far. Does anyone have any questions or thoughts, insights about what you've seen? Note that John does love the flashing white screen. Maybe not love it enough to keep it if we could fix it though.
All right, so skipping over this stuff, unfreezing this, running once more. All right, so this is doing a lot more work, which is what I wanted to see. So if we remember before over on my Revit model, I had very few things in there in terms of the overall sort of views in my project browser. Still nothing in here. We've got just our 3D view, but the key piece is within this content. I've sort of display all the gathered flattened surfaces that I pulled together there. I've built a few key functions here. So we're going to get the largest facing upward surface by area. That's going to be the walk line of the tread. From there, with those individual surfaces, I'm going to go ahead and I'm going to get the inside arc of the face. The way I'm doing that is this custom function that's going to take the edges of the topology, convert those to curved geometry, remove if those pieces are not an arc, get the radius of the arc to sort of give me the center point, or sorry, the inside arc for each one of those faces. I'm going to go ahead, I'm going to turn off this display geometry so we can have a look at just what those are. So there's those, you can see them there. And now if I come back and turn on this again, you can kind of see where those darker curves are all kind of on the inside face of our other arcs. All right, so now moving on from there, we're going to take those objects, get the center point of the arc, and get a midpoint on the arc, and then create a vector by those 2 points, right? So this should be a totally flat vector from the center point to the end. We'll go ahead and we'll pull the cross of that vector and the z-axis, and then reverse that vector. The reason I'm doing all of this is I want to build a new coordinate system. And when I do that, that coordinate system looks like this. So remember what I said before, our z-axis wants to be kind of the depth for all of our views. X-axis on kind of the red, and y-axis is going to be up. I go ahead and I translate that coordinate system, take its XYZ or ZX plane and rotate that coordinate system by 180 degrees to give me these coordinate systems. Now I've got coordinate systems on top of coordinate systems on top of coordinate systems. So let me go ahead and hide some of this stuff. We'll hide this as well because it's getting a little bit busy. And then with all those rotated coordinate systems, we can start to gather some stuff up. But before I do that, so these are going to be our kind of RCPs. These are going to be our plans, right? So reflected ceiling plans, our plans were kind of down here, right? And then over here, we've got our sections. So we're going to take, again, those same curves. We're going to get the midpoint and the center point, define that vector again. That's going to be equal to our x-axis. We're then going to take our y-axis and set that to be equal to our z-axis and our cross. And again, we're going to turn this on. And I'm going to hide these pieces again here. And with these, those are equal to all my sections. So you can see we've got spacing from the middle of those points. If I come up into the top, we've always got something that's going to be kind of perpendicular to the center of each one of those planes. We'll pull that XY plane, rotate it 90 degrees to make sure, 90, negative 90, 90, 90, and negative 90 to give myself a series of planes, and then translate it by some dimensions. These dimensions are basically going to be driven by the dimensions of my geometry. You know, if I went backwards by 0.875 feet, which I think is like 7.5 inches or something like that. That's going to go ahead and, no, 9.5 inches. I don't know. That's going to go ahead and give me a point just before the center post for all my stairs. If I go out 3.75 feet, that's going to give me one that's just beyond the end of my stairs. And as a result, I wind up in one in between. As a result, I wind up with all of these coordinate systems that I just turned on here. So we've got one that's looking at the inside face of my stair, one that's cutting through my stair, and one that's looking back at the outside face of my stair. And with all of those, we gather them up and then we can pass them on. But I did, as always, build a handy little create sheet and views. This allows me as a designer to go through and parse this content out to make sure it's showing up the way that I might like it to. I'm going to go ahead and hide these, and then we're going to get into the actual magic. Apparently I didn't hide everything. And we'll go ahead and we'll get into the actual magic here. I'm going to pull this off to one side and we can watch both our views and sheets, because what I'm going to do next is going to make both of those. Toggle that and hit run. That was pretty quick, huh? So you can see here, we've got a whole bunch of sections that have been created. Right, 222, no sheets yet. Let me see if we can figure out exactly what went wrong there. Element.name is failing on our object identity, which is passing a function from.
You deleted the connection to that.
I deleted the connection to that, and I'm not sure what that was originally connected to.
It goes to, yeah, the original box.
Here we go. Great catch.
Debugging on the fly.
Great eyes, Sol.
Yeah, I took note of it when you did it. I kind of cheated. This is the most amount of coordinate systems I think I've seen in a single graph. Unless somebody's been trying to like create coordinate systems on a surface and just playing with it and getting crazy numbers.
There we go. All right, so now all my sections have been named correctly. Beyond that, they're all on sheets, and each one of those sheets has been named correctly. So now I can start to open this up, and we can see here what we've got. We've got our plan, reflected plan, our floor plan, our elevation at the interior posts, our section, cross section, our elevation at the exterior guard, and our longitudinal section through the entirety of the stair. And we've got that for all 37 different unique stair parts, which is pretty crazy. And you can see it's got that all the different sort of parts of the geometry are all pulled through. And the other cool thing about this, if anybody's ever tried to dimension anything that's sort of non-linear, I'm going to go ahead and move this, and we'll activate that view. Unless everything's perfectly perpendicular, you can't snap. And the likelihood of me being able to manually draw in all that stuff and actually get it so that it was perfectly perpendicular is pretty slim, but it just works here because, again, it's computationally driven. It can't be wrong, right? Which is, again, one of those really big benefits to doing the work this way, right? And it goes
caveated with the fact that if you use your logic or define your logic correctly.
Yes, the logic does have to, great point. So the logic does have to be sort of set up correctly, but you can see it's all there. And yeah, we've got some unique dimensions, but those were pretty much intentional because we've got crazy shapes that we were kind of after here. Maybe we might want to sort of rationalize those back at the geometry creation phase, right? Move stuff up by 3/32 of an inch or down by a 32nd of an inch. I don't know which direction we might want to go, but it all does work, which is pretty cool. All right, so back here, let's go ahead and let's talk back about the graph, kind of what the different phases we're doing. So after I gathered all this stuff into the code block, this looks like it's a lot of work if I zoom out, right? But in reality, all it's doing is saying, clean the list. If make views is true, go ahead and pass the reflected plan. Otherwise, we're past null, right? And that was literally just done so I could have this sort of true false Boolean set up once and sort of not have a million crisscrossing lines. So if that was true, we're going to go ahead and pass the coordinate system for the plan. If it was false, we won't. So we've got our coordinate system coming into that section view by coordinate system min-max. We've got our minimum coordinates, maximum coordinates. These are hard-coded, again, based on the dimensions of my stair. That's going to get our reflected ceiling plan. Then we're going to go ahead and create the plan view. Then we're going to go ahead and create the interior post dimensions. And it's all the same code, just slightly different, right? The heights on these might change, right? In terms of our minimum maximum point, like min point on my cross sections is always going to be 0 because I want that min point down at the elevation 0, so on and so forth. So with all that content kind of set up and all my views created, we pass it on to the rename views. And that's just a whole bunch of, again, management of my list, right? So we're passing the content through into view name plus elevation name. Our view name is equal to elevation name plus reflected plan at tread, so on and so forth. From there, we'll gather all those renamed views up into one list, transpose the list. So instead of having all my plan views together or ceiling plan views together or whatever, we've got everything by tread. And then we're going to go ahead and permanently isolate each one of the elements that we passed along from way back in the beginning that I disconnected originally in the view. Set the view scale to 1 inch equals 1 foot. And then go ahead and place them on our sheet with the sheet by name, number, title block, and views. Might be nice to have set those up to sort of control the location on the view using name, sheet number, title block, views, and locations. But because each one of my sections was a different size, it didn't really make sense to just have a consistent point for all of those. We're going to have to get a little bit creative with how we place stuff on the sheet just to make everything fit. So that's the workflow in a nutshell. And I've got 13 minutes left, faster than I had expected, even with the crash.
Nice. There is a post, I think, by John on generative design and like the placement of views on sheets. It could be a follow-up to this particular graph once you've actually got them on sheets.
Great point. And that's a great workflow too.
So obviously we didn't cover everything. You know, we noted in the presentation that you can do a bunch more stuff after this around the creation of dimensions. If you want to get really technical, you can do stuff like setting the aesthetics of the views and the sheets and a whole bunch of different things that we didn't have time to do in a particular 1-hour session here today. But the world is your oyster, and the benefit of doing this kind of workflow is, especially if you set it up in a reusable way, is if you're doing repeatable components in your projects. So you're doing commercial buildings and you want to do room data sheets. This is the exact same kind of workflow you would do to create a room data sheet. And that can be set from the center of a room and just reused on every single project you have after that, providing you test it on a bunch of different projects and work out the crinks or the edge cases that may exist. And so what you can do is you can start using automation to start saving yourself a lot of time and effort in the documentation phase, bearing in mind that it won't do 100% of it. And this should be like a first pass. You should have yourself or somebody else in your office going through and doing a manual check afterwards and adding in those kind of elements that you can't automate today. Some esoteric dimensions, some of the sort of like the overrides, some of the graphic or aesthetic choices that are not currently expressed in the Revit API, which means you can't access them in Dynamo, or not yet expressed as Dynamo nodes out of the box.
It's a great point. One area where I used to use this back when I was practicing is in documentation of kitchens, because they need a lot of sections, right? They need a lot of elevations, and you can sort of automate the creation of all those different parts and pieces pretty quickly, which is quite nice.
Yeah, this is more of a computational thought process as well as part of the workflow rather than the full piece. But there's a lot of education to be had from this approach. And some of the hard-coded pieces that Jacob has in here around like the actual specific dimensions of things like the stairs, you could obviously do without hard coding. You could start pulling those kind of more nuanced elements from, say, the dimensions of your geometry to get a more reusable format that wouldn't break if we make changes to the geometry. But in this particular case, it is relatively baked. So there's always choices to make.
Yeah, for the kitchen workflow, we did calculate that based on parameters of the elements and dimensions of the geometry, but where we didn't have parameters here, right? I don't know what the height of these pieces are necessarily, and B, we don't have geometry that we can quickly pull over. Some content I am able and was able to pull over, and that would be stuff like, you know, the height of the elements is going to be consistent dimension above, so on and so forth. So you can get some of that content, but not necessarily all.
Yeah, we have you know, notions of large scale operations. So you can think of things like building metro stations, you know, building a massive sort of MEP projects where there is tons and tons of rooms looking to dimension the same kind of elements together. And you can talk about like weeks and weeks and weeks worth of effort saved by using an approach kind of like this. You know, large joint venture projects around the world, it's sort of the higher end, the larger end of the scale. We might be talking like 3,000 different sheets you have to create to dedicate to different elements or pieces of a particular complex building. And automating the process of creating that is huge when it comes to saving time, and time is money. So a big win all around. So do we have any questions? None I see in the chat right now. If anyone has any questions, apart from Ashkan, who's looking for the Dynamo graphs, which we'll post after the session is finished. So we were still working up until about 10 minutes before the session kicked off to do final tweaks on the presentation, which, you know, hashtag last minute is something we do sometimes, / all the time. So we will post those after this. And if not, we can maybe go through the final slides in our deck and call it a couple of minutes early, which is rare for us. So we have a bunch of new sessions coming up. So this was the third of a 3-part series in specifically taking some complex geometry created from Dynamo, putting it into Revit, flexing it, and now documenting part of it. The next session that we have coming up on the 9th of March is called Packages of Note. And this has some special guests from Autodesk Research. So Reese Goldstein and Ken Walmsley are going to be showcasing 2 packages that they have created as part of the Dynamo ecosystem, and a few other people also contributed to them around the Vasa package, which is talking about voxelization or converting things into Minecraft kind of aesthetics, and the space analysis or 2D space analysis package, which is talking about doing things like view shaft analysis, shadow analysis, and like points, sorry, what's the word for it? egress pathing, and so on. So that's going to be 2 other packages we're going to talk about. We're also going to talk about a bunch of other packages that we have inside of the sort of Dynamo ecosystem from inside the fence of Autodesk. So stuff like Dynamo Text and the Mesh Toolkit. And then we're also going to note a handful or a small sub-selection of packages from out in the community that we want to highlight for various reasons, but bear in mind that's not going to be exhaustive. Beyond that, we're going to have a 3-part series working in Civil 3D. So the first of those on the 23rd of March is Going with the Flow, talking about pipes inside of Civil 3D. We do have special guests we're talking to. We haven't quite locked that in yet. So hence the question marks on this one. The next one in that series is going to start talking about GIS data in Civil 3D using Dynamo with a special guest as well. And then we have one more in that series to come. And then a bunch of other sort of spec'd out classes for the rest of the year actually available on the Dynamo forum. So I will find and ping that link in. But we have lots of cool stuff, mostly workflow oriented for this year to round out our Dynamo Office Hours series.
All right, so hopefully we will see you all in the community in some way, shape, or form after this, and at least back here for the other events that Saul and Jacob are hosting. These are some links, and they will all be listed on that event page that is in the chat currently. Just other ways to get involved, whether you want to attempt to host your own community conversation, or if you wanted to get involved in some other way. These are all of our avenues for you to do that. We are also on social media, which are all linked there. And yeah, that is kind of where we're at for the community stuff. So thank you all for joining, and thank you, Saul and Jacob. As always, it was wonderful to have you guys here hosting. If anybody else has any other questions, now is the time to quickly ask in the chat. Otherwise, we will wrap up and hopefully see you guys at the next one.
Thanks everyone for joining us today. We hope to see you at the next set of the series.